Okay, let us discuss this problem. This is a slightly interesting problem related to anti and syn elimination. So draw the diagram and then we will discuss. So if you have written this side, I can go something like this. Okay, so what this problem says, if you treat this compound, so this compound, you see this is a particular stereochemistry, so this compound has a stereochemistry. If you treat this compound with excess CH3I Ag2O, what will happen if you treat with excess CH3I? That is called exhaustive methylation. First you will add nitrogen 1 methyl group, and then you will add another methyl group, and then you will have a plus charge, and then you will lose H plus from here, and then you will get alkene. This is given here. So you are getting an alkene. So this is a basic method of formation of an alkene, and this is called Hofmann elimination. So excess CH3I and Ag2O heat. If you heat this one, this is the leaving group. So this will go, and from here you will have a product. So this is given to you that this product is formed. So this is given, like the product is given to you. Also given, if you treat this compound with metachloropurbenzoic acid, there is a something that is formed. Now if you heat that compound, you will get something like this. If you see this stereochemistry, this side you have CH3 and this big group CH3 are anti to each other. But if you see here, this side CH3 group and CH3 both are same side. So this is something kind of cis kind of thing. And if you see, this is something of trans kind of thing. Basically this is E and this is Z. So now you have to say why this is so. You have to draw the transition state for these two reactions and show the arrow. So one elimination is basically Hofmann elimination, another elimination is a Cope, that is called Cope elimination. So you have to draw the transition state to show the product. So what you have to do is you have to draw the card arrow, how the things is going on. You have to show the stereochemistry in the arrow flow. So you can take the this kind of anti-configuration, you can form anti-elimination. In one case you form syn elimination. In this case you will have NO minus that will be formed. I will give you a hint. In this case, with MCPBA there are something formed that is NO minus that forms a hydrogen bond. So it is given that this nitrogen attaches with oxygen minus that forms a hydrogen bond, and that says it is possible only if we have a syn configuration. So let us take 2-3 minutes time and then we will discuss the solution. Okay, let us come to the now solution part. Maybe some of you have tried. So let us do what we are saying. If we have this compound, now Hofmann elimination is always anti. So this means if I have this compound, if I have to lose this one, this leaving group, I have to put hydrogen on the bottom side. So this means I have to make one something like rotation kind of thing. If I rotate this one, then I need hydrogen on the downside. If I do hydrogen downside, what will happen? I have to rotate by 180 degree. I can get only this if I rotate by 180 degree. Are you getting out about this bond? If I rotate about this bond, so hydrogen will come down, and whatever that is forward side will go inward. So this is forward side, it will go inward. Now here you have CH3, that is inside, it will come forward side. Are you getting it? So, and that will be slightly above. So it will be initially it's flowing down. Both are basically downside. Now it will be upside. So both are upside. You see this is forming a vertical bi. Here it is forming a inverted bi. Now you can show the arrow. This OH minus will take, H plus will go here, and this Ame group, methyl group, NMe3 plus group will go. So this is the leaving group. And if you just do this one and you just make flat this molecule, just give a force so that the molecule becomes flat, You see CH3, CH3 and H both will be same side. This group, that is the below the plane of paper and comes the same side. So finally, well, these two are same side. Now if you see here, this CH3 and CH3 that is above the plane, if you make the molecule flat, it will come above the plane, something like on the same side. Now you see, if you see the second one, this is called co-elimination. Here I have already said this forms an intermediate with O minus H2O2 or any perbenzoic acid. So if you have a per acid, it forms a O minus intermediate. Now this O minus basically makes hydrogen bond with this oxygen, and this is possible only if these two are basically opposite. So you see, if I want to make a hydrogen bond, I don't have to do any rotation about this one. This is always orientation in which it can form a hydrogen bond. So this nitrogen with oxygen forms a hydrogen bond. So you see, this is a how many cyclic transition state? 1, 2, 3, 4, 5. So this will be a hydrogen bond. So if this is a hydrogen bond, so this arrow will go here. So this oxygen will take hydrogen. Same time this bond will come here, and the same time this bond will go something like this. Are you getting it? So this bond will break. So you see, you have a double bond here. Now this double bond, you see CH3, that is the inside, hydrogen inside. So you will have CH3 and H both inside. Now CH3, CH3 and CH3 both upside the plane. So here also you have that is upside of the plane. Are you getting or not? So you just copy this one. And then this is syn elimination. You see, in this case both groups, that is the hydrogen as well as methyl ME, both are going from the same side. So this is a kind of syn elimination. So co-elimination goes with the syn elimination, and Hofmann elimination goes with the anti-elimination. Are you getting or not? I can show the same thing with Newman projection also. So you see, I can make the Newman projection of this molecule. So this molecule, if I look from this side, what I will see? I will see the top I have NMe3 plus, and then so NMe3 is on the top, and then I have, if I see from your left side, you will have hydrogen, right side CH3. On the front carbon, left side hydrogen, CH3 right side. On the back carbon, if I see, this OH is downside, so OH will be downside, hydrogen, sorry. So this hydrogen is the downside, so I will put hydrogen downside. Now you see here, this group, the big group, that is left side, and CH3 is the right side. So you put it here. So this is the CH3 is the right side, and this group is the left side. You see here, of course, you see this group is left side, this group is right side. So big group is left side, and the small group is right side. Now you do elimination, OH minus will take H plus, and this will goes. And now you make the molecule flat, this CH3, this CH3, so this goes down slightly, and this goes slightly up, this goes slightly down, so that molecule becomes planar. So you will get the same formula. You are getting it. So both CH3 on the same side. So you see here, both CH3 and this Me group opposite, and CH3 and hydrogen will be opposite. So you see here, you will get the same thing. Are you getting or not? If you do the next one, this is for Me3 plus. Now if you do for this one, Me2O minus, again in this case you will have to make an eclipse conformation. If you make the eclipse conformation and do the same kind of thing, so H plus goes from here and this group goes from here, and you make flat, so you will have CH, Me2 and Me one side. So CH on this double bond will have along this plane, so this is C1, inside you have C2. So one side of the double bond you will have Me group and CH Me2 group. So one side of the double bond you will have Me group and CH Me2 group. Another side of the double bond you have CH3 and H. Another side of the double bond you will have CH3 and H. Here also you see, one side of the double bond you will have CH3H, CH3. So you see here, one side of the double bond you have CH3, another side of the double bond you have CH3 Me2 and H. So you see here, another side you have CH3 Me2 and H, CH Me2 H. Are you getting or not? You are able to see this molecule or not? If you are not able to see, I can make something like this, slightly bigger, because red colors is sometimes not easy to see on the screen. So let me make slightly CH3 CH CH3, this is also CH3. Okay, so now have you done this problem or not? So let us copy this one. I will wait for some time so that you can copy all the things, and we'll discuss the next problem. You can make a pause on the screen and then go for the next problem. Okay.